Hello everyone, welcome back to the Atharva Gate Academy. In previous video, we have discussed sign convention, equation of shear force and bending moment, and we have seen some example based on the shear force and bending moment diagram. Now in this video, we are going to see more example based on the shear force and bending moment diagram. So this is the first example. In this example, this is the beam AB which is cantilevered at end B. Here end A is free and we apply point load P in downward direction at point C. Distance between A and C is A. And for this example, we have to find out shear force diagram and bending moment diagram. So let us see how to do it. Here you can see there is two interval AC and interval CB. So first of all, we are going to calculate shear force and bending moment for the interval AC. For interval AC, value of x is 0 less than or equal to x less than A. Here we are not going to take C point, we are taking left side part of point C. So here we are not putting less than or equal to sign. Here we are taking only less than sign. In this interval, what is the value of shear force F? To finding out shear force, we will take a section between this interval. Let's say this is the section which is at the distance x from this end. So if we want to find out shear force at this section, then we have to take sum of all the transverse force left side of this section. As you can see here, there is no any transverse force acting left side of this section. So value of shear force F will be equal to 0 in this interval. Now in this interval, what will be the value of bending moment M? To find bending moment in this interval, we have to take sum of all the moments produced by the transverse force acting at the left side of this section. Now here there is no any moment or there is no any transverse force acting at the left side of this section. So value of bending moment M also will be equal to 0 in this interval. Now we are going to take the second interval which is CB. So for that, range of x will be A less than or equal to x less than or equal to L. Here total length of this beam is L. So to finding out shear force and bending moment in this interval, we will take section between this interval. The distance of this interval from this end A is x. Now at this section, we want to find out shear force. So what will be the value of shear force? To find shear force, we will take sum of all the transverse force acting left side of this section. Here you can see there is only one transverse force, that is P, and which is in downward direction. So we will take it negative. So it will be minus P, right? Now what will be the value of bending moment M? Now here, first method to finding out bending moment is we can directly take sum of all the moment produced by the transverse force acting left side of this section. So here there is only one transverse force, that is P. So we will take moment produced by this transverse force P. So what will be the moment produced by this force? It will be this load P into distance between this load and this section. What is the distance between this load and this section? This whole distance is x and this distance is A. So this distance will be x minus A, right? So here we can write that moment M is equal to P into x minus A. And here this moment will try to bend this beam like this. Means there will be hogging in the beam. So we will take this moment as negative. And we can also take it negative because this force P is in downward direction at the left side of this section. So we will also take it negative. So by that you can also understand that this moment will be negative. Now this is the first method to finding out bending moment. We can also find out bending moment M by integrating shear force. Now here what is the value of shear force? That is minus P. So bending moment will be equal to integration of minus P into dx, right? So it will be equal to minus px plus c. And here this c is the constant. Now understand carefully that at the point C, what will be the value of bending moment? The value of bending moment will be 0 at point C, because at the left side of this C point there is no any bending moment or there is no any transverse force. There is a transverse force P acting directly on the point C. So the distance between this load and this point is 0. So finally the value of bending moment will be 0 at this point, correct? So we can write that at C value of x is equal to a, right? This distance is a, and at that point bending moment m is equal to 0. So if we put this condition here, then we will get 0 is equal to minus pa plus c. Value of c can be find out. C will be equal to p into a. And if we put value of c at this place, so finally we will get bending moment m is equal to minus px plus pa. And if we take minus p common from this equation, then we will get this equation. Bending moment m is equal to minus p into bracket x minus a, correct? Now here we are going to draw the shear force diagram and bending moment diagram. So first of all we will draw shear force diagram. For that we will take this direction as a x direction, and in this direction we will take shear force F. Now here there will be the A point and distance will be x is equal to 0. Here there is C point. So at this point this distance is A, and this is the point B where this total distance is L. Now to draw shear force diagram, first we will draw shear force diagram in this interval. Now in this interval, that is 0 to A, what is the value of shear force? Value of shear force is 0. So we will draw a line on the x-axis. From here to here, value of shear force will be 0. Now in this interval, that is x is between A and L, what is the value of shear force? In this interval, value of shear force is F is equal to minus P. So here our shear force diagram will be like this, and here this distance will be minus P. This horizontal line shows that shear force is constant throughout this interval. Now if you remember, I have told you in the topic of type of load that point load gives sudden effect on the shear force diagram and concentrated moment gives sudden effect on bending moment diagram. Now here you can see there is a point load P at the point C. So this point load is going to give the sudden effect on shear force diagram like this. And also there will be a reaction in the vertical direction opposite to this load at this point B. So there will be also a sudden effect on shear force diagram at this point. So it will be like this. So finally this will be the shear force diagram for this example. Okay. Now here we want to draw the bending moment diagram for this example. So here we will take this direction as a x direction, and in this direction we will take bending moment m. Now here there will be also two intervals. One interval will be from this point to this point, and second interval will be from this point to this point. This point is at the x is equal to 0, this point is at the x is equal to a, and this point is at the x is equal to L. Now what is the value of bending moment in this interval? In this interval, value of bending moment is 0. So from here to here there will be 0 bending moment in this beam. So we will draw a line on the x-axis like this. And in second interval, what is the value of bending moment? In second interval, value of bending moment m is minus p into bracket x minus a. To get the value of bending moment m at x is equal to a, we will put value of a instead of x. So if we put A here, then value of bending moment will be 0. So we will get this point. And what will be the value of bending moment at this point? At this point, value of x is L. So we will put L instead of x. So what will be the value of bending moment? Bending moment will be minus p into bracket L minus A. And this will be negative because here value of L is greater than A. So at this point, that is x is equal to L, we will get negative bending moment, and that is minus p into bracket L minus A. And as you can see, this equation is the equation of line because here the power of x is 1. So there will be a line joining these 2 points. So we can draw like this. Now here this point load P will produce a moment at this point B, right? So there will be a reactive moment at this point B like this. Now I have told you that concentrated moment gives sudden effect on bending moment diagram. So here at this point it will be a vertical line like this. Okay? So finally this will be the bending moment diagram for this example. Correct? I hope you understand the method. I am again going to repeat this. Now here we are going to discuss the second example. In this example, there is a beam AB which is a cantilever beam and fixed at the end B. Here, this is the uniform distributed load. If you don't know, just remember that uniform distributed load can be also shown like this. And here value of uniform distributed load is W. Now in this case, we want to find out shear force and bending moment diagram. So here first of all we will take interval, that is 0 less than or equal to x less than or equal to L. Now in this interval we want to find out value of shear force and bending moment. So for that we will take a section which is at the distance of x from the end A. Now how to find out shear force at this section? We know that to finding out shear force at this section, we have to take sum of all the transverse force that are acting at the left side of this section. So here you can see at the left side of this section, there is this uniform distributed load is acting. And what will be the value of total load by this uniform distributed load? We know that total load will be equal to area of the uniform distributed load diagram, this load into this distance, that is the area of load diagram, right? So it will be equal to W into X, and it is in downward direction, so we will take it negative. I hope you remember it, right? Now here this is the first method to finding out shear force. We can also find shear force F by integrating Wx, that is the value of uniform distributed load W. Here in our case the value of W is constant throughout the length, so it will be equal to integration of W, and it will be negative because this is in the downward direction. So finally we will get shear force is equal to minus Wx, right? Now how to find bending moment M in this interval? What is the equation of bending moment? Equation of bending moment is integration F into dx. Now what is the value of F? F is equal to minus Wx. So it will be equal to integration of minus Wx into dx. So it will be equal to minus W x square by 2 plus C. Now we have to find out value of constant C. For that we will put boundary condition. If you remember, I told you that if at the free end, if there is no any bending moment applied like this, then value of bending moment will be 0 at that point. So value of bending moment M will be 0 at x is equal to 0, right? So if we put value of x is equal to 0 here, then value of bending moment will be 0. So finally it will be equal to 0 is equal to 0 plus c. So value of c will be equal to 0. So finally we will get bending moment m is equal to minus w x square by 2. Correct? So now we have value of shear force, that is minus wx, and we have value of bending moment, that is minus wx square by 2. Now we will draw the shear force diagram here and bending moment diagram here. Here we take this direction as a x direction, and similarly this direction will be x direction. In this direction there will be a shear force F. This point is point A where x is equal to 0, and this point is point B where x is equal to L. Similarly, here there is one point where x is equal to 0, and this is the point where x is equal to L. Now here if we put value of x is equal to 0, then we will get value of shear force as 0. So finally we will get this point where x is equal to 0 and value of shear force is 0. And if we put value of x is equal to L, then we will get shear force at point B, which will be equal to minus WL, and it is negative. So here at this point, which is x is equal to L, we will get value of shear force that will be negative, and this distance will be minus WL. Now here you can see the power of this x is 1. So this is the equation of line. So we will join these 2 points by line. So it will be something like this. Now as discussed in the earlier example, there will be a reaction in vertical direction like this, and there will be a reactive moment in this direction at this point B. So here this load gives the sudden effect on the shear force diagram. So we will join these 2 points like this, and this concentrated moment is going to be give the sudden effect on bending moment diagram. So finally this is the shear force diagram. Now here we are going to draw the bending moment diagram for this case. Here in this direction we will take bending moment m. We have value of bending moment is minus w x square by 2. If we put value of 0 instead of x, then we will get bending moment m is equal to 0 at point A. Correct? So we will get this point. At this point x is equal to 0 and m is equal to 0. Now if we put x is equal to L, then we will get bending moment m at point B, which will be equal to minus WL square by 2. So at this point value of bending moment will be minus WL square by 2. It is negative, so it will be in the negative direction. So let's say it is at this point, and value of this distance is minus WL square by 2. Now here how to join these 2 points? Here you can see the power of x is 2. So it is not the equation of line. So we cannot join these 2 points by line. This is having power 2. So it is the equation of parabola. So here we have to join these 2 points by parabolic curve. Here we are going to understand that how to draw the parabolic curve. Here we can draw parabolic curve like this, and we can also draw it like this. Here in this first curve, the curvature of this parabola is in the downward direction, and in this second curve, the curvature of this parabola is in upward direction, right? So how to decide that which curvature is correct for this bending moment? For that we have to take double differentiation of this equation. So first of all we will take dm divided by dx. It will be equal to minus w into 2x divided by 2. So here 2 will be cancelled out and it will be minus wx. And now we will take second differentiation, that is d square m divided by dx square. So it will be equal to minus w. Differentiation of x will be 1. Here you can see that double differentiation of bending moment is negative, and if the double differentiation of equation of any curve is negative, then the curvature of that curve will be like this. Means the curvature of that curve will be in the downward direction. And the double differentiation of any equation of any curve comes as positive, then the curvature of that curve will be upward. At this time you have to remember this, but we are also going to learn this in the engineering mathematics part. So right now our double differentiation of this equation is stop here negative, and so we are going to more example in the next video. Till then, try to understand the method, because the curvature of this shear force curve and is bending moment diagram downward direction. Okay, so finally this curvature will meet in the next video example. Thank you for watching, and here we will join this 2 point. So this will be the final bending moment diagram for our example. I hope you understand it, that how we take this curvature in the downward direction. If it is not clear to you, you can repeat this video and watch it again. Now let us discuss this example. In this example, there is a beam AB, which is a cantilever beam of length L, and here distance between A and C is A. We apply uniform distributed load W between point C and B. In this case, we want to find out shear force diagram and bending moment diagram. It is little bit similar as the previous example, but difference is only that between A and C there is no any load. So here we will take two intervals. First interval will be 0 less than or equal to x less than A. So here we will take left part of this point C. In this interval we will take this section which is at the distance of x from point A. Now at this section we want to find out value of shear force and bending moment. So what will be the value of shear force? As you can see here, there is no any transverse force acting at the left side of this section. So value of shear force will be 0 at this interval. Now we want to find out value of bending moment in this section. So what will be the value of bending moment? Now again, there is no any transverse force or any bending moment acting at the left side of this section. So again, value of bending moment M will be 0. So in the interval A to C, there is no any shear force and there is no any bending moment. Now let us take this another interval, that is interval CB. For that interval, value of x will be between A and L. Now we want to find out value of shear force and bending moment in this interval. For that, we will take a cross section, or we can say a section at the distance of x from the point A. What will be the value of shear force in this interval? If we want to find out value of shear force at this section, then it will be sum of all the transverse force acting at the left side of this section. Now here at the left side of this section, there is a uniform distributed load up to this length. So what will be the total load due to this uniform distributed load? We know that total load is equal to value of uniform distributed load into the distance over which the uniform distributed load is applied. Here what is the distance over which the uniform distributed load is applied in the left side of this section? This distance is this. And what is the value of this distance? It is x minus A. So it will be x minus A. And it is in downward direction. So our final shear force will be negative W x minus A. Correct? Now we are going to find this shear force by using the equation. So what is the equation of shear force? It is the integration of uniform distributed load at x distance into dx. Now here the value of uniform distributed load is constant throughout the length. So it will be equal to integration of W into dx. Now here this uniform distributed load is in the downward direction, so we will take this W as a negative. So what will be the shear force? It will be minus Wx plus C, and here C is the constant for integration. Now we will find value of constant by putting the boundary condition. Now what is the value of shear force at point C? To finding out value of shear force, we will take section here and we will see the left side of the force acting on the beam. Here you can see there is no any force acting at the left side of the point C. So at the point C, value of shear force will be 0, and at the point C, value of x is A. So x is A. Now if we put this boundary condition in this expression, then it will be 0 is equal to minus WA plus C. So finally we will get value of C is equal to W into A. Correct? And now we will put value of C here. So finally we will get shear force F is equal to minus Wx plus WA. Now we will take minus W common from this expression. So it will be equal to minus W into bracket x minus A. And it is the similar as this. Right? So here I just show you how to find out shear force from this equation. Now we want to find out bending moment M in this interval. We know the equation of bending moment is integration of shear force. Here we have the shear force F. So we will put this value of F here. So it will be integration of minus W into bracket x minus A into dx. So what will be the integration of this part? It will be minus W into bracket x square by 2, that is integration of x, minus Ax, that is integration of A, and plus C, which is the constant for integration. This is the bending moment M. Now here you can see that power of x is 2. So this equation is the equation of parabola. Now we are going to draw the shear force diagram and bending moment diagram. Here there will be the x direction, and here in this direction there will be value of shear force, and in this direction there will be bending moment M. Here first of all we will mark this 3 point. There is the point A at this point there will be C at the distance of A, and this point will be point B. Similarly here this point is A, this point is C, and this point is B. Now here in the interval of 0 to A, value of shear force is 0. So it will be a line on the x-axis from point 0 to point x is equal to A. And also value of bending moment is 0 in this interval. So there is also will be a horizontal line in the x-axis from point A to C. Now we are going to take this interval. In this interval, value of shear force is this. Here you can see that the power of x is 1. So it will be the equation of line. Now to draw a line, we will take 2 points. First is at the x is equal to A, and second is at the x is equal to L. First of all, we are going to put x is equal to A. Then what we will get? We will get F is equal to 0, because here A minus A will be 0. So here we will get this point. And now we are going to put x is equal to L. If we put x is equal to L, then we will get F is equal to minus W L minus A. Now here value of L is greater than the A, so finally shear force at the x is equal to L will be negative. So it will be below this x direction, let's say here. And here this distance is minus W L minus A. Correct? Now as we know, this equation is equation of line. So we will join these 2 points directly by a straight line like this. Here we apply this distributed load in downward direction. So there will be a reaction at this end which will be in upward direction and which will be the point load. And if you remember, I told you in the notes that the point load gives sudden effect on shear force diagram. So this is that sudden effect on the shear force diagram, which is a vertical line joining these 2 points. Okay. Now we are going to draw the bending moment diagram between this interval. Now in this interval, what is the value of bending moment? Bending moment is minus w into bracket x square by 2 minus ax. Now in this equation there is c that need to be find out. For that we will put boundary condition at point C. Now at point C, similarly at the left side of this point C, there is no any bending moment and there is no any transverse force. So value of bending moment will be 0 at the point C. So m will be equal to 0 at x is equal to a. If we put this in this equation, then it will be equal to 0 is equal to minus w into bracket x is equal to a. So it will be a square by 2 minus a square bracket over plus c. So finally value of c will be equal to minus w a square by 2. So instead of c, here we put minus w a square by 2. Okay. Now we know that this equation is of parabola because here the degree of x is 2. First of all, we will find two endpoints of the parabola. For that, we will put x is equal to a. So here, if we put x is equal to a, then we will get bending moment m is equal to 0. That you can do it by yourself. So we will get here this point. And now we are going to put x is equal to L in this equation. So bending moment m will be equal to minus w into bracket L square by 2 minus a into L bracket over minus wa square by 2. In exam, all values will be given to you, so you can directly put values here and find out m. But right now, if you simplify this, then bending moment m will be equal to minus w by 2 into bracket L minus a square. Here value of L is greater than a and there is a square, so this term will be positive, and here there is negative, so finally bending moment will be negative. So here value of bending moment will be below this axis. So let's say it is somewhere here, and here this distance is minus w by 2 into bracket L minus a square. Now we have to join these 2 points by parabola. And there is again one question, that curvature of parabola will be in upward direction or it will be in downward direction. So for that we will take double derivation of this equation. And if you do it, then it will be d square m divided by dx square, and it will be negative. You can do it by yourself. So the curvature of parabola will be in downward direction. So it will be something like this. So here we are going to draw the parabola having curvature in downward direction like this. We have also discussed that at the fixed end there may be 3 support. One is in vertical direction, one is in horizontal direction, and there is also a reactive moment like this. Now here there is no any horizontal force acting on the beam, so there will be no any horizontal reaction at this point. But due to this uniform distributed load, there will be a moment acting in this beam. So there will be a reactive moment at this end, and that will be a concentrated moment because that reactive moment will act at the point B. And we have discussed that concentrated moment gives sudden effect on the bending moment diagram, so that we will join this 2 point like this. So I hope it is clear to you, right? You have to practice these examples because without practicing you cannot do it correctly in the exam. Okay? Now in this video we will stop here and we will see more example in the next video. Till then, try to understand the method of finding shear force and bending moment diagram. Okay? So we will meet in the next video. Thank you for watching.